Hello everyone and welcome to today's class. My name is Calabo Beke Divine and I'm going to be your instructor on Physics 101. So let's go. So today we'll be looking at some key topics in Physics 101 and we'll be solving them together. So we're going to be starting with the very first topic, units and measurement. Then we'll move to what? Dimensional analysis. Then we'll move to stored energy stored in an elastic material, vector, rotational dynamics and angular momentum, motion, work, energy, and what? Power. So make sure you're with your writing materials because we are going to be solving together. So let's go. So the first thing we have is what? Units and measurement. So for units and measurement, we have length, and we know that length, the what? SI unit for length. First of all, let me define unit and measurement. In physics, a value without a unit is just a lonely number. We use SI, that's the System International Units, to ensure that everyone is speaking the same language. And in the SI units, we have fundamental units and we have derived units. So for the fundamental units, we have the first one, which is what? Length. And for length, the unit for length, which is the unit for length is what? Meters. The unit for length is meters. And the symbol for that is what? M. While the unit for time is what? Seconds. And the symbol is S. We have that the unit for mass is what? Kilogram. And the unit is what? K what? G. So that's what we have for mass. We also have for what? Electric current as what? Ampere. And the unit, the symbol is what? A. We have for temperature as what? Kelvin. And the unit for temperature is what? K. We have for amount of substance as what? Mole. And the symbol is what? Mole. We also have for luminous intensity as what? Candela. And the symbol is what? CD. So these are the words. These are the SI units and their symbols, and these are the what? Fundamental quantities. So for the fundamental quantities, they are also known as the base quantities. Then derived quantities, these quantities are quantities gotten from the combination of two or more what? Fundamental what? Quantities. For example, we have area, and we know that for area is equals to what? Length times breadth, and we know that length is measured in meters and breadth is also measured in what? Meters, which will give us what? Meters what? Square, which will give us what? Meters what? Square. And meters square is the same thing as what? L square. Remember, we are using the MLT format, where M is the what? Mass, L is the what? Length, and T is the what? Time. And we know that L is measured, and we know that L here is measured in what? Meters. Look at it. Length, meters, length, meters. So when we do length times breadth, we get meters times meters, meter square, which is the same thing as what? L square. So next off, we have velocity, and velocity is what? Displacement over what? Time. And we know that displacement is also measured in what? Meters, and time in what? Seconds, which will give us what? Meters is represented as L and time is represented as T, which is giving us L over T. We can also write it as what? L raised to the power minus 1, LT raised to the power what? Minus 1. Next up, we have acceleration. We know that acceleration is also giving us what? Velocity, or is known as velocity over what? Time. And for that, we know that, let me bring it down here. Acceleration is what? Velocity over time. Acceleration is equals to what? Velocity over what? Time. And we say that velocity is what? Equals to what? Lt raised to the power minus 1, which is here. Lt raised to the power minus 1. And we know that time is also represented as t. So time will now be what? Lt raised to the power minus 1 all over what? T. And from our law of indices, we know that Lt raised to the power minus 1 is still the same thing as what? Lt minus 1 divided by what? T raised to the power what? Minus what? 1. And if we further break this down, we will now have that when we are dividing the same base, which is t and t, we'll do what? We'll subtract their powers, right? So we'll now have acceleration as what? L what? T raised to the power minus 1 minus what? Another 1, which will now give us what? L T raised to the power what? Minus what? 2. So this is all we have for what? Acceleration. So we'll now have that acceleration is equals to what? Lt minus 2. Next up, we have density. We know that density is equals to mass over volume. Mass over what? Volume. And we know that mass is measured in kilogram and volume is what? Length times breadth times height. And we know that length times breadth times height are all measured in meters. So it will be m times what? M. And kilogram, as we said before, kilogram is what? The unit for what? Kg is unit for mass. And we said mass is represented as m. So we'll have that kilogram, which is mass, is represented as capital M, right? And we have that small m, meter times meter times meter, is the SI unit for length, meters. And we see that length is described or is represented as what? L. So we'll now have that what? Small m will now be capital M all over L times what? L, which will give us what? M over L raised to the power 3, which is also the same thing as what? M L raised to the power minus what? 3. So we'll have that density is what? M L raised to the power minus what? 3. So that's what we have for what? Density. Next up, we have power. Power is the same thing as what? We have power as what? Mass times acceleration times distance. Mass times acceleration times distance, because power is equals to what? Work done over what? Time taken. And work done is what? Force times distance, right? Let me write it here. We have that power is equals to work done over what? Time what? Taken. And we know that work done is what? Force times what? Distance over what? Time. So force is simply what? Mass times acceleration, right? Force is what? Mass times acceleration. And distance is there, that is times distance. All over what? Time. We will now have that what? Mass is measured in what? Kilogram. Acceleration is what? Lt square. Acceleration is what? Lt raised to the power minus 2. Lt raised to the power minus 2 times the distance. Distance is also measured in length, which will give us what? L over time, which is t. So we'll now have that what? Kilogram. We know that kilogram is same thing as mass, which is represented in m, times what? L. L times L will give us L square times what? T raised to the power minus what? 2 all over what? T. So we'll now have power as equals to what? T here and T here. It's now be M L square t raised to the power minus 2 divided by what? T raised to the power minus what? 1, which will now give us what? ml square t raised to the power what? Minus 2 minus 1, which is equals to what? ml square t raised to the power minus what? 3. So that is what power is. Ml square t raised to the power minus what? 3. So let's write it down here. Power is what? ml square t raised to the power what? Minus 3. Next up, we have pressure. And we know that pressure is the same thing as force over area. Pressure is what? Is equals to what? Force over what? Area. And we know that area is length times breadth, which is length is measured in meters and breadth is what? Measured in meters. And we know force is mass times acceleration. And we know that mass is what? Kg times acceleration. And our acceleration, which is here, acceleration is what? Lt minus 2, mass times acceleration, which is what? Lt minus 2. And we know that mass is the symbol for we know that kg is the symbol for mass and kg is represented in m. So it will be m times Lt raised to the power minus 2. I know that meters is represented as L times what? L. So we'll have that M, we'll have that what? M Lt raised to the power minus 2 over L square, which is the same thing as what? M Lt raised to the power minus 2, MLT raised to the power minus 2, what? Divided by L raised to the power minus what? 2. So we'll now have that what? M L, that's 1 minus 2, that's raised to the power 1 here minus this power 2, and t raised to the power 2. I will have that. Our final answer will be what? M L raised to the power minus 1, t raised to the power minus 2. So that's what we'll have for what? For pressure. Pressure will be what? M what? L raised to the power minus 1, t raised to the power minus 2. So let's write it down here. M L raised to the power minus 1, t raised to the power what? Minus 2. So pressure will be what? M what? L raised to the power minus 1, t raised to the power minus what? 2. So Young modulus, let's go to Young modulus. We have Young modulus, right? For Young modulus, we'll have that Young modulus, also known as E. Young modulus, also known as E, is equals to what? Stress over what? Strain. And we know that stress is what? Force over area. And we know that strain is what? Dimensionless. L, change in length over what? Original length. Alright. So for that, we know that force, which is here, MLT raised to the power minus 2, over area, which is also the same thing, force over area, which is pressure. Okay, let's just write it at once. Force over area, pressure, okay. L square all over. This is dimensionless. L to cancel L, we'll be left with 1. 1. So we'll have that Young modulus will be the same thing as what? Pressure, which is what? L, ML raised to the power 1 minus 1 and T raised to the power what? Minus 2, because now this will now cancel out this. So 1 will cancel out 1 here. So here we're left with nothing and here we'll be left with just 1 L. So we'll now have ML raised to the power minus 1 and T raised to the power what? Minus 2. So let's go and write it down there. So what else do we have? So we have Young modulus as the same thing as pressure, which is M L raised to the power minus 1 and T raised to the power minus what? 2. So next up we have gravitational what? Constant. Then we have work. We've already found out work. We say work is equal to force times distance, which is mass times acceleration times distance. And this is it here, M L square times T raised to the power minus 2. So let's write it down. So work is what? M L square T raised to the power what? Minus 2. So what is left now is the gravitational what? Constant G. So for gravitational constant, if you can remember, you know that G is equals to, now G is equals to what? F arrow square all over what? M1 times what? M2, where F is the force and the force is what? M L T raised to power 2 times arrow is the radius and radius is in length, so is what? L square all over the mass of two bodies, and mass is in what? Kilogram, which is kg square. So we now have what? M what? L 1 plus 2 T raised to power what? Minus 2 all over M square. So M here will cancel M. I'll be left with one M here, right? So we'll now have that what? This M now will now be what? M raised to power 1 minus 1. L1 plus 2 is what? L raised to power 3, and T raised to power what? Minus 2. So that's what we'll have for what? G. M raised to power minus 1, L raised to power 3, and T raised to power what? Minus 2. So let's write it down. So we'll have gravitational constant as what? M raised to power minus 1, L raised to power 3, and T raised to power what? Minus what? 2. Alright, so we are done with what? The fundamental and derived units. We are done with fundamental and derived units. So the next thing we'll look at is dimensional analysis. So we are done with this. So the next thing we'll look at is what? Dimensional what? Analysis. So for dimensional analysis, we'll solve two different what? Examples. The first one, they say we should verify the what? Correctness of the what? Equation. And the second question, they say the speed of a sound in a material medium depends on the modulus of elasticity, that is E. They say the speed of a sound, the speed, that's the speed V, is what? Proportional, that's it depends on what? Modulus of elasticity E and density rho. So this is the equation for the second one. Why this one? They say we should what? Check if this is dimensionally correct. So let's do that. Doing that, we'll have solution. We'll have our solution. Our solution to be what? We say that S is equals to what? UT plus what? Half AT square. So checking if it's dimensionally correct. S is the distance covered, and distance is what? L, which is equals to U. Let's write it here. S is equals to what? L. U is initial velocity, right? And is equals to what? LT raised to power minus 1. Acceleration A is equals to what? LT raised to power minus what? 2. Then T is equals to what? T. And we have T square is equals to what? T what? Square. So if we have all this as S, this S now is equals to L. We have U is equals to LT raised to power minus 1. We have T as T. We have A as LT raised to power minus 2. And we have T square as T square. So we'll now have that what? We'll have that. So we'll have that what? S, which is L, is equals to what? LT raised to power minus 1, which is this U, LT raised to power minus 1, times T, times what? T, plus what? Plus what? Half A. A here is what? LT raised to power minus 2. And we have T square as what? T square. Alright, so if we proceed, we'll now have that what? L is equals to what? T raised to power minus 1 and T raised to power 1 will now be what? L what? T what? Minus 1 plus what? 1 plus 1 over 2 into what? L, which is this one. T raised to power what? Minus 2, which is that one there. then plus what? 2. So L, which is this, t raised to the power minus 1 plus t raised to the power 1 plus 1 over 2, 1 over 2, L, which is this, and t raised to the power minus 2, which is this, plus 2, which is this 2. So this will be eliminated. So this will cancel out. This 2 will cancel out. So we're left with L is equals to what? L plus what? 1 over 2 what? L. So that's what we're left with. So if we add these two, we'll now be left with what? L is equals to what? 3 over what? 2 what? L. So if you check the left hand side and the right hand side, they are in what? L. So this equation is what? Dimensionally correct. How we got 3 over 2? The coefficient of L here is 1. 1 plus half is what? 3 over 2. So let's proceed. So we are done with the first example. We are done with the what? First example. We are done with this. We have verified the correctness of the equation. So now let's go to the second one. They said V. They said the speed of a sound. That's speed. That's V. That's the velocity of the speed of a sound in the material medium depends on the modulus of elasticity E and the density. You know that we have gotten speed, the SI unit for speed, which is this. Where is it? That's velocity, which is LT raised to the power minus 1. And we have for modulus of elasticity as what? Young modulus, look at it here. ML raised to the power minus 1, T raised to the power minus 2. And we have for density as what? ML raised to the power what? Minus what? 3. So having all that, we'll now what? Simply substitute. Before we do that, we'll bring out our constant. So let's solve. So let's go. To do that, say the speed is directly proportional to the what? Young modulus and what? The density. And we know that V is equals to what? LT raised to the power minus 1. We know that young modulus is equals to what? Let's check. Young modulus. V, that's velocity of speed, is equals to LT raised to the power minus 1. Young modulus is equals to ML raised to the power minus 1, T raised to the power minus 2. Let's write it down. So we have it as what? M L raised to the power minus 1, T raised to the power minus what? 2. And we have density as what? M L raised to the power what? Minus what? 3. So we have gotten the what? SI units for each of the quantities. So now we'll now bring out our what? Constant, which is K. Is now equals to what? E times what? That's young modulus times density. This K is a constant. So we'll now substitute. We'll now have that what? LT raised to the power minus 1 is equals to what? K into what? M what? L minus 1. This is for young modulus. T what? Minus 2. Put it as what? All into what? X. And we'll now have density as what? M L raised to the power minus 3. All into what? Y. So for further breakdown, we'll now have what? LT raised to the power minus 1 is equals to what? K. Expanding, M will have what? M times X. M here is raised to the power 1 times X. So now be M raised to the power X into what? L raised to the power minus 1 times X equals to what? Minus X. And we'll have T into minus 2 times X will be what? Minus 2 what? X. Then this one is a times here, right? So it's now be times what? M times Y. M raised to the power minus 1 times minus, sorry, let's cap. M has raised to the power 1 here, right? So 1 times Y will give us Y. And L minus 3 times Y will give us what? Minus or 3Y. So we are expanding the bracket. So after expanding the bracket, we'll now have this. So next thing is to what? Collect like terms, collect the common base. M and M here, we'll collect them. L and L, we'll collect them. Then T will be left alone. So we'll now have what? LT raised to the power minus 1 as equals to what? K what? M X what? Since they're multiplying, you add their powers plus Y. You have L raised to the power minus X. Since L raised to the power minus X is multiplying L raised to the power minus 3Y, you add their powers. So plus times minus, so now give us minus, right? So it now be minus what? 3Y. Then we'll bring out T raised to the power what? Minus 2X. But if you check this part of the equation, there's no value for M. So let's insert M. Since there's no value, we'll put it raised to the power what? 0. So now what? Equate their what? Coefficient. So for M, For M, we'll have that what? X plus y is equals to what? 0. And for what? L, we'll have that minus x minus 3y is equals to what? 1. So we're taking their coefficients, we're taking their powers. So the power here is what? X plus y is equals to 0. We got it here. We have minus x minus 3y is equals to L raised power 1, right? So L is 1, so you get it here. So we now have minus 2x is equals to what? Minus 1. So let's write that for t. For t, we'll have that what? Minus 2x is equals to minus 1. So if we are to simplify this equation, if we want to simplify this equation, let's start with x. So since minus 2x equals to 1, we'll have that x, if we divide both sides by minus 2, here we'll cancel out here. Minus will cancel out minus. We'll now have that what? X is equals to what? 1 over 2. So if we put x as 1 over 2 here, we'll now have 1 over 2 plus what? Y is equals to 0. Therefore, we'll have what? That y will be equals to what? Minus 1 over 2. Because we'll take 1 over 2 to this other part, so it's now become negative. So now we have our value for what? Y, and we have our value for x. So remember, from the beginning, we put Young modulus in terms of x and density in terms of y. So we have gotten the value for x and y. So we'll now bring it back. So we'll now have that what? V is equals to Young modulus. First of all, we write the constant equals to Young modulus E in terms of x, right? And density in terms of what? Y. So we'll now have it as what? V is equals to K into E raised to the power half. That's 1 over 2 times what? Density raised to the power what? Minus 1 over 2. So this is what we'll have. But we can simplify it further to have that what? V is equals to K. Now, from the law of indices, the fractional law, 1 over 2 is simply what? Root what? E times what? Negative. We'll now make it what? 1 over what? Root rho. So, we'll now have our final answer to be what? V is equals to the constant K into square root of Young modulus over what? The square root of what? Density. So this is what we'll have as our final answer. So we have completed example number what? 2. We see we should what? Show the exact form of the relationship. So this is the relationship they gave us. So where speed is proportional to Young modulus and density, and we have shown them the exact form. So this is the exact form here. So moving on, we are done with dimensional analysis. So we are done with dimensional analysis, right? So we'll move towards energy stored. We are done with dimensional analysis. So we'll move towards energy stored in an elastic what? Material.